Hi and welcome to this tutorial. Today we did a model of the air blast explosion over a composite column or beam. Here you can see we have aluminium as the internal box. Then we have four different CFRP layer with cohesive interaction between each layer and cohesive interaction between the aluminium and CFRP. And if I click on animate here, sorry, the last frame, click, see, this is the blast load. And first let me this is the final frame. First let me check the aluminium as an internal surface, and now let me use feature edge to have a better view of the failure. See here, it is filled completely, the aluminium box as the internal layer. And then the Johnson Cook damage, see here, we use Johnson Cook model for it here, and you can see here this is the Johnson Cook damage, you can see it. And we can check also plastic strain or anything else for it. It is filled completely, see that it is filled completely. And this is the stress, see the blast load and the stress. And this is the final view. Now let me check CFRP1, the first layer in interaction with the aluminium. It is filled also, see, all the elements removed. Let me check hushing damage, see, hushing damage for this layer, tension damage, it is filled completely, compression damage, tension damage for matrix, and then CFRP2, the second layer, see here again, CFRP3, you can see all the elements filled. And the last one, CFRP4, see the CFRP4, it is filled also. And you can check other damage types of the model. Let me replace all, then check it in this view. See here in the side view, see the lamination happen here, see here, all the, it is filled, we can say it is filled completely in all the views. So if I click on animate, you can check it here, the damage, see the deformation, and then we can check the tension damage for the fibers here, aluminium failure under the blast load. The blast load is the convex method. You can use also SPH acoustic or the CEL method or Eulerian method. And this is the final results of the model. See here, you can see that. Also you can check the history output for the reaction force here. See the reaction force for the strain energy, total energy, kinematic and internal energy. You can see the kinematic is the blue, it is too high, and it means it is completely dynamic model. So also you can check the cohesive failure between the layers, cohesive interaction failure, or any other damage type that we can use in Abaqus. So if you need to model the blast load over a composite beam or column which is made by aluminium and CFRP layers, separate CFRP layers with cohesive behavior between the layers, you can use this tutorial. So if you need it, come out to our website here, abaqusfm.com, find the English tutorial here, or search it in the search section in the website. Then click on title. Here you will have the geometry, assembly, a step interaction load, and then the result as figures you can see here. You can provide CA English video file, INP file, the codes, and the reference for the material just for 26 euros. You can use a PayPal account, Visa or MasterCard for the payment. Contact me to tell you about the payment process here. Also, we have a full package of Abaqus modeling and simulation, containing more than 400 tutorials. It covers everything in Abaqus, and you will learn anything and all aspects of modeling and simulation by using this full package. You can read about the full package here, the main titles, also the subtitles here, about explosion, impact welding, biomechanics, forming, cracked soil, CFD, FSI, thermal analysis, thermal structure, cyclic, masonry, discrete element method, Pilates, composite material, concrete structure, steel, seismic analysis, electromagnetic, anything. So if you want to provide this really exceptional full package with the affordable price, contact me to this email to tell you about that. So thank you for your attention.